Hello and welcome to Cool Fire News, your go-to source for all things tech. I'm your host, Siri, and today we're diving into the fascinating world of hardware description languages, or HDLs. Whether you're a tech enthusiast, a budding engineer, or just curious about how digital systems are created, this episode is for you. So, what exactly is a hardware description language? Simply put, HDLs are specialized computer languages used to describe the structure, design, and operation of electronic circuits. They're like the blueprints for digital systems, allowing engineers to design and simulate everything from microprocessors to custom chips before they're manufactured. The two most popular HDLs used in the industry are VHDL and Verilog. Each has its own unique strengths. VHDL is known for being rigorous and precise, making it a favorite for complex designs. On the other hand, Verilog is often praised for its simplicity and ease of use, perfect for beginners who want to dive right in. HDLs are essential in the development of the digital devices we use every day. From smartphones and computers to cutting-edge technologies in aerospace and healthcare, HDLs enable the creation of sophisticated electronic systems. They allow engineers to simulate their designs, ensuring that everything works perfectly before hitting the production lines. Now, let's talk about HDL programming. Programming in HDL involves writing code that describes the behavior and structure of electronic circuits. This is done through modules and components, which can be tested and simulated using HDL software tools. HDL programming is a skill that can open doors to various career opportunities. By learning to code in VHDL or Verilog, you can become a key player in fields like digital design, semiconductor manufacturing, and embedded systems. Let's also touch on two fundamental types of circuits you'll encounter in HDL programming: combinational and sequential circuits. Combinational circuits are those whose output is a pure function of the present input only, like adders and multiplexers. On the other hand, sequential circuits depend on both current and past inputs, incorporating memory elements like flip-flops. Another key area to explore is HDL constructs. These are the building blocks that make up the HDL code. In VHDL, for example, we use constructs like entities, architectures, processes, and signals to define the behavior and structure of circuits. In Verilog, you'll encounter modules, always blocks, and assigned statements. Understanding these constructs is essential for writing effective HDL code. They help in organizing the code, making it easier to simulate and debug your designs. Now, let's dive into another important aspect of HDL: operators and modeling functionality. In HDLs, operators perform operations on data objects. These include logical operators like AND, OR, NOT, arithmetic operators like addition and subtraction, and relational operators for comparing values. Mastering these operators is crucial for building and modeling complex digital systems. When it comes to modeling functionality, HDLs allow you to model various aspects of digital systems, from simple logic gates to complex processors. This is achieved by defining the behavior of these systems using the constructs and operators we've discussed. An integral part of HDL design is behavioral modeling, which describes what a system should do, rather than how it does it. Behavioral modeling allows you to focus on the algorithmic level, providing a high-level abstraction of the system. In addition to behavioral modeling, procedural constructs are used extensively in HDLs, especially in languages like Verilog. These constructs include initial and always blocks, which are essential for creating loops, conditionals, and concurrent executions in your HDL code. Now, let's talk about counters, a key component in sequential circuits. Counters are used to store and count binary data and are integral for tasks such as timing and state tracking in digital systems. Designing counters using HDL involves understanding flip-flops and creating state transitions. Real-world applications of HDL counters are diverse and significant. For instance, in consumer electronics, counters are used in digital clocks and timers. In telecommunications, they're essential for data packet management, helping to synchronize signals and manage data flow. In industrial automation, counters are crucial for controlling processes, such as monitoring production line speeds or counting items. They are also found in automotive systems, where they help in functions like odometer tracking and engine control units. I hope this episode has given you a clear picture of what HDL is and its crucial role in the tech world. It's a powerful tool that drives innovation and keeps the digital world spinning. If you have any questions or thoughts about today's topic, feel free to reach out to us on our social media channels.